We're going to prove, so go ahead and put your book away for right now. We're going to be taking some notes and proving a couple of these theorems here, okay? So have your paper out for notes. It's going to be separate from your theorem. First thing we're going to do here, we're going to prove that there's 180 degrees in a triangle. Yesterday, we showed that if you take the angles of a triangle and you add them up, it gives you 180 degrees. You all did it by measuring your own triangles. Some of us were off by a degree or two, maybe even 4. It's fine, but it should add to 180 degrees. I proved by using the angles of a triangle that if you rip off the angles and put them all together, it gives us 180 degrees, forms a line. We're going to do the same thing today, only we're going to prove it. Okay? Anytime we do a proof, this is the given information. First part is the given, second part is what we're trying to prove. So, we are given triangle ABC. We are trying to prove the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. First thing we're going to do is, how do we draw a triangle, ABC? And I'm going to make this angle A, make this angle B, I'm going to make this angle C. Now, you may be like, oh, okay, Mr. Kuhne. Normally, Mr. Kuhne, you tell me to look on my theorem sheet because it tells me something I can use. Problem is, we don't have anything yet. So we're going to do something a little bit sneaky. Okay? We're going to make a parallel line. I'm going to make a line parallel. Line L is parallel to AC. And I'm going to call this angle 1. I'm going to call this angle 2. Suddenly we're getting really excited. We're getting really, really excited. Why are we getting so excited? Because we have parallel lines. Also because we have a line up here. And we know some things about a line. Okay? We know some things about a line. How many degrees are in a line? 180 degrees, right? Look on your theorems and definitions page. Okay? Look on your theorems and definitions page on the front page there. Okay? Do you see something that kind of looks like a line with some angles on it? Under the given information. The very front of it. Right here, where it says linear pair, it says angle 1, it's got a picture of angle 1 and angle 2. Okay? And if we know that's true, it says I can come over here, it tells me exactly what to write. Okay? We use this. The theorems are easy. If you don't use this or you lost it, okay, you're like a piece of wood. Okay? You're screwed. Okay? If you don't use this, theorems are going to be hard. You use it, theorems are going to be easy. So, we're going to start here. We're going to say, hey, measure of angle 1 plus the measure of angle B plus the measure of angle 2 equals 180 degrees. The reason? We're just going to write down they form a line. That's easy. Okay? The next thing we have here, L is parallel to AC. We drew L parallel to AC. Okay? If we have parallel lines, though, that tells us some things. Okay? If you look on your theorems and definition sheet, we have some things from chapter 3. Once again, if you look on your theorems and definition sheet, this one didn't have one. This Viscous, may I borrow yours real fast? Is this it right here?
Yep.
If we look on our theorems and definition sheet, it's got all sorts of cool things where it says A is parallel to B, A is parallel to B, A is parallel to B, A is parallel to B. Anything where lines are parallel, we know we can use that. Okay? we know we can use that. So, if we look on here, we got line A parallel to line AC. Which angles have to be congruent? Take 20 seconds. For example, let's just start with angle 1. What is angle 1 going to have to be congruent to because those lines are parallel? Take 20 seconds, talk with your partner. Go. 3, 2, 1. Angle 1 is congruent to what? Everybody. 1, 2, 3. Angle A. What kind of angles are those? They're not corresponding. They're alternate interior. Now, if you're having trouble seeing that, you're normally like, Mr. Kuhne, I only see the alternate interior angles like this. Like, these are alternate interior, Mr. Kuhne. Yes, they are. All it is, we don't have all the stuff going on there. A good hint for alternate interior angles, anytime you see something that looks kind of like a Z, and the lines are parallel, those are alternate interior. All right, so angle 1 is congruent to angle A. Right here. So this tells us angle 1 is congruent to angle A because they're alternate interior. But not just angle 1 and angle A. What else has to be the same? Mr. Chu sees it. You're thinking angle 2 and angle?
Angle 2 and C, right?
Angle C, yes! Awesome! Fantastic. Those are also alternate interior. Do you see the kind of the Z thing going on there? Alternate interior. A to Z, alternate interior. So great. So we got angle 2 is congruent to angle C by alternate interior angles. Now that's really, really great. We're getting really excited here. Peyton's really excited. Because he's like, no, Mr. Kuhne, if they're congruent, then they have to be equal. He's like, so that means the measure of angle 1 is equal to the measure of angle A. But that's the definition of congruence, because I use my theorem from definition sheet. And the measure of angle 2 is equal to the measure of angle C, also by definition of congruence. But suddenly, Sean's like, oh wait, Mr. Kuhne, I see it! I see it! If 1 is the same thing as angle A, I can come up here and plug in what? What can I plug in, Sean? Angle A. I'm going to take this and shove it in right there for angle 1. Measure of angle A plus the measure of angle B plus... And Scott can't help herself. She's like, oh, Mr. Kuhne, I see it too. Angle 2, I don't want angle 2, I want angle C. I want angle C. And so I'm like, yes, that's absolutely right. So she says, I'm going to plug in angle C, measure of angle C. And so by substituting those in, we get A plus B equals, A plus B plus C equals 180. That's what we're trying to prove, QED. There's 180 degrees in the triangle. Any triangle. Okay? Any triangle. Alright, now, you may be like, Mr. Kuhne, what's the big deal about this? Well, once again, we use this so we can prove other theorems. Okay? We use this so we can prove other theorems. We're going to be proving the exterior angle theorem in just a moment here, but first we're going to do a couple examples of this. Okay? Because we know it's always true, now we're actually going to use it. So let's do an example problem here. I will give you 30 seconds to solve this with your partner. This angle right here is 80 degrees. This angle right here is 70 degrees. I need to know how many degrees angle 1 is, okay? And then I want you to classify the triangle by its angles. Okay? So, take 30 seconds right now. Find out how much angle 1 is. Find out how much angle 1 is. Go ahead and begin. Go. Talk about it with your partner. Talk it out. 3, 2, 1. Student number 12. Who's student number 12? Oh, student number 12. Okay. Sir, how much is angle 1?
The 60.
Why do you say 60?
I don't know, but I was listening to him.
Okay. Well, let's start here, okay? You know this is 80, right? How much does that angle got to be?
80.
Why? What kind of angles are those?
Because they're corresponding.
Not corresponding. They are vertical. Thank you, Mr. Kincaid. Thank you for helping me out there. So those are vertical angles, so those are the same. Excellent. Great. So that's 80. So now, how many degrees are in a triangle, sir? 180. So how many degrees do we have down here if we add these together? 120? What's 7 plus 8? 18?
I don't know.
7 plus 8?
Hey, I got you.
What is it?
15.
It's 50. So 70 plus 80 is 150. Thank you. So if it's 150 degrees, how much does angle 1 have to be? All together. Ready? 1, 2, 3. 30 degrees. Did we answer the question though? We found angle 1, but what classify the triangle by its angles? All together. 1, 2, 3. It's acute. We couldn't answer that question until we knew how much angle 1 was. Got to find angle 1 first. Okay? All right. Slightly different problem here. Let's see here. 3x, 2x, and 5x plus 80. Find the measure of each angle. All right. If only we knew how many degrees were in a triangle, Mr. Kuhne, maybe we could add all those up. Oh wait, we do know how many degrees are in a triangle. Set it up with your partner and solve it. You have 30 seconds. Go.
Let's go.
What do they all add up to?
He did it wrong. Yes, I did.
Got it? Yeah, got it? Ready?
Why?
And I'm good? No. Sure you do. How many degrees are in a triangle?
It's x equals 2.
Okay, so how do you do that?
Did that with common sense.
You did by common sense. Okay, so let's show me your common sense. So how did you set it up? How did you solve this?
How I solved it?
Yeah. You just magically guessed that x equals 10.
No, I did 5 plus 3 is 8 plus 2 equals 10.
Okay.
You're making it complicated.
No, I'm not. You add them all up, right?
Do it in your head.
Okay, so we get 10x plus 80 equals what?
180.
180. Yes. Okay. Now what do we do?
Now what I did was, I thought this is 180, so I just added the 8 to the 10, so therefore, each has to be 10.
Okay, so this has to be 10, so there's a little algebra. We said that's got to be 100, so x equals 10. All right, so we did a little bit. So, not rigorous, but you just get some steps. Okay, you got the right answer. Yes, okay. So x equals 10, but you didn't answer the question. How much is each angle? Find the measure of each angle. How would you do that, sir?
You would plug x in,
Yeah, plug x in. Okay.
and then, so, 3x would be 30,
So this one would be 30. Great.
2x would be 20, and then 5x would be 50, but add 80, so that's going to be 130.
So that gives us 110. Great. What kind of triangle is it? Obtuse, acute, right, or equiangular?
That's me.
Yeah.
Juice.
It's obtuse. Excellent. Pretty simple. 180 degrees in a triangle. Okay, sometimes we have to use some vertical angles, or you have to do linear pair. No problem. Okay, we're going to prove the exterior angles theorem now. Yes, sir?
Still up to 110.
Oh, I said 100. I'm sorry, it should be 130. My fault. All right. So, we're going to prove the exterior angles theorem now. A little bit of a precursor on this, just kind of show you what's going on here. Quick intro problem here. If I said this is 100 degrees, and I said this was 50 degrees, and you had to find this angle right here, okay? You have to find that angle right there. We're going to do a quick little math problem here. We can figure this out easily. If this is 100, this is 50, how much does this angle right here have to be? Shout it out. Ready? 1, 2, 3. 30 degrees. Yes, this has to be 30. Now, if we ignore all this, these two angles form a line, don't they? How many degrees are in a line? 180. So if this is 30, how much does this have to be? 150. But wait, Mr. Kuhne, you said these are, if these add up to 150, don't they? These add up to 150. So this angle on the outside is equal to this plus this. Okay? But we're going to do this using, we're going to do it in a proof now. Okay? We know it's true for this case. Is it always going to be true? So we have to do a rigorous proof. Okay? Remember, we always want to show that something's always true. Okay? Something's only true some of the time. That's bad news bears. Just think how great it would be if your cell phone only worked some of the time. Well, for some of you that's true, right? Is it a little frustrating? It only works some of the time? Alright, angle 1, angle 2, and angle 3. Okay? And over here we're going to say this is angle 3 and this is angle E. Pause for just a moment. Do you see how this picture right here is the same as this up here? I just split it up into two parts. I drew the triangle over here, and I drew the exterior angle over there, didn't I? All right. No problems here, because we can use our theorems and definition sheet. Our theorems and definition sheet. We've got a triangle. What does the theorem and definition sheet tell us about if we got a triangle? Sir? Okay, so what would we write here, sir? Equals 180. Perfect. Great. Fantastic. Brilliant. And that's the Triangle Sum Theorem. All right. Over here, if you flip over your theorems and definition sheet, right on the front of it, we've got a picture that looks like this. What picture looks like this on the front? Ms. Anderson. Linear pair postulate. The pictures looks like this. So what is it? What does that tell us to write, ma'am? Yes. Measure of angle 3 plus the measure of angle E equals 180. That's the linear pair postulate. Now the great thing about this is, Cat goes, oh my gosh, Mr. Kuhne, they both equal 180. If they both equal 180, then they have to be equal to each other. Yes. So that means, I'm going to take this, I'm going to come over here, I'm going to say, they both equal 180, so they equal each other. That's the transitive property. So we say measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to measure of angle 3 plus the measure of angle E. There's only one thing standing in our way from world domination, or dominating this theorem anyway. What's the one thing standing in our way there, ma'am? We're trying to get 1 E is the same as 1 plus 2. What's the one thing standing in our way? Get it? You see it? We got 1 plus 2 plus 3 equals 3 plus E. So what has to be the same? We have 3 on both sides. We can't, all we gotta do is subtract it. So subtract angle 3 from both sides. The measure of angle 1 plus the measure of angle 2 equals the measure of angle E. This angle right here is the same as this plus this. That's what we're trying to get to. We've put a QE at the bottom. If you use your theorems and definition sheet, these are easy. If you lost your theorems and definition sheet, this is going to be really, really hard, especially in the coming chapters. So if you don't have it, Ms. Viscas might make some copies for you. She's really, really nice. And maybe if you bring her in her own bag of Coke, okay, ask her nicely, maybe she'll make some copies for you, okay, of hers. So, the 3 big things we have here today: 180 degrees in a triangle. Really easy to do. Exterior angle theorem. These 2 add up to that. Okay. This one, you got one of the angles is 90 degrees. You can easily figure out that the other 2 have to add up to 90. Okay. All right. Your homework tonight. You look on the board up there. This is assignment number 2. You've got 11 problems from this section, and you've got 4 problems from last section. Homework's page 250, numbers 1 through 11, and page 241, numbers 15 through 17, and number 46.